Hi class. So we'll look at the next section. We began by looking at characteristics of exponential functions. And so now we'll look at the transformation. So this is pretty similar to what we've looked at before, looking at other functions and transforming them. So if you look at the framework here, it's pretty similar. K is responsible for vertical translation, so going up or down. What's significant about K is that'll alter the horizontal asymptote. So remember, for the base function, the horizontal asymptote is y equals 0, and so that'll change according to what K is. H is your horizontal translation, so that'll shift you left and right. Remember, it goes by the opposite sign. And then you have your stretches. Here we're using A as the letter for the stretch, and that's the vertical stretch, and B is the horizontal stretch. And remember, with the horizontal stretch, it is the reciprocal that you're multiplying by, and then C is the constant. Okay, I think in the previous set of notes that we used the letter A for the constant, but sometimes it's given by C. Okay, so let's start with a graph here. Let's begin with y equals 4x as the base graph, and so we'll do this exactly the same way we did before. We'll take the coordinates of the base graph and then map out the new coordinates. Okay, so for the base graph is y equals 4 to the power of x, and so here we can go for 0, it's going to be 1. For 1, it's 4. And for 2, it's going to be 4 squared, which is 16. Okay, so let's take those coordinates, and now let's graph the transformed equation. Okay, so I'll write out the coordinates: 0, 1, 1, 4, and 2, 16. Okay, so remember before, we always take care of our reflection stretches first, and then we take care of the translation. Okay, so first thing we can do is we can, if we look at x, we're multiplying by -2, so what we'll do here is we'll multiply x by -1/2. Okay, so remember it's the reciprocal. Okay, so for the first one it stays 0, 1. The second one is going to be -1/2, 4. And the third one is going to be -1, 16. Okay, there's no vertical stretch, so now let's do a translation. You're going, you see how it says x plus 5, so that means you're going left by 5. So that means your x value, you're going to subtract 5, so you got -5 and 1. You've got -5.5 and 4. And then you've got -6 and 16. Okay, and then the last thing here is these values are going to go down by 3. Okay, because it's -3. So what you're going to get, and these are your final coordinates, is your y value is going to be subtracting by 3, so 1 turns into -2. We've got -5.5, and then 4 turns into 1. And then we've got 16 that's going to turn into, it's not 12, sorry, 13. Okay, so there's your new coordinates. Now, before we begin, let's just talk about the horizontal asymptote. Okay, so the original function would have had y equals 0 as the horizontal asymptote. this one here is going to be y equals to -3. Okay, so that's a result of the vertical translation. So what we can do to start, let's make a grid, and then we'll draw in the vertical asymptote first, and then we'll put all the points on there. Okay, so if I go, I'll call this 12 and 15. And we'll call this -3. Okay, so there's your -3. So what we can do is we can put a horizontal asymptote here. So it's always good when you're translating something, have your horizontal asymptote written in. So basically what that shows you is where you don't want to be touching. Okay, so that's kind of like a boundary. Okay, and so we can plot our coordinates that we have. So we got -5, -2. See, I haven't put the, I have to put the values in for x. So let's do that first. So let's see where our x goes from -5 to -6. So they're all going to be on the left-hand side here. So don't really need to worry about the right-hand side. Okay. So the first coordinate I have here is -5 and -2. So it's around there somewhere. Then I've got -5.5 and -5.5 and 1. Okay, so I don't really have a coordinate there, so I'll just put that around here. And then we've got -6 and 13. Okay, and that's just around here somewhere. Okay, so what we have here again is something that's not going to touch the vertical asymptote. But remember, what a vertical asymptote means is that you're close to it. Okay, so there's sort of your rough sketch of your transformed graph. Okay, now let's. So we talked about the horizontal asymptote, the domain and range. So the domain for this function is going to be all real numbers. The range is going to be y is greater than -3, not equal to. So remember, it never touches the asymptote. And now let's look at the intercepts. So the intercepts for this function. So remember, a base function never touches the x-axis, so it doesn't have an x-intercept. But this one is going to have one because we've performed a transformation on it. Okay, so the x-intercept is going to occur when y equals 0. So what you do is you basically sub in 0 for y. Okay, and so you can move the 3 over to the other side. And so Now what you want to do here, because this is kind of tough to solve, you want to estimate different values of basically a trial and error method where you sub in values for x and you kind of want to look at what's going to work. Okay, and when you do this, this isn't going to be exact. I am going to show you sort of an exact way to get the solution later on here. But for right now, just sub in different x values and use visually, look at your graph. Again, this was a rough graph, right? But if you look at the graph, it should be after all these values here that are all negative. I forgot to put the negative sign, but -1, -2, -3, -4, -5. So it looks like it's before -5 or left of -5. And so you can confirm that when you put that in, and what you'll find is you'll get an answer roughly, so I'm not giving an exact answer here, between -5 and -5.5. Okay, and so put that in for x, and that'll show that it works. And where I'm getting these numbers from is visually from the graph. And then for the y-intercept, here we make x equal to 0. And basically what you have here, when you do that, is you're going to get 4 to the -2. X is 0, so it's just going to be times 5 minus 3. So you're going to get 4 to the -10 minus 3. Now, if you do that in your calculator, what you're going to find is that's going to be a really, really, really tiny number, 4 to the power of -10. And then when you minus it by 3, it's going to be very close. So again, I'm giving an approximate answer here. This is going to be close, but close to -3. Okay, so again, both these answers that I've just given for the intercepts, between -5 and 5.5 and close to -3, both of these answers here, these are approximations. Okay, so they're not exact answers. Like I said, I'll show you how to get exact answers later on. Okay, let's look at working the other way now, where you're given a graph, and now you want to try to figure out what is the equation. Okay, so here's a decay model for iodine. So an isotope of iodine, 131. And so what you notice here is it starts at 100% on the vertical axis, and what happens is it keeps going down by 50%, which is the definition of what we call a half-life. And the half-life here, this is happening every 8 days if you look at the horizontal axis, right? First 8 days it drops to 50%, then the second 8 days, 8 to 16 days, it goes from 50% to 25%, right? So it keeps getting chopped in half. And so what's happening here is the values decrease. Okay, so this is a decreasing exponential, decrease by a factor of 2. Okay, so what we can start off with here as a base function is y equals 1/2 to the power of x. Okay, so this is our base function. Okay, so now let's see if we have to add in any transformation. Okay, so looking at all the letters that we have from that transformation, what you're seeing here is that it decreases every 8 days, right? So according to the horizontal axis. So what we have here now is we can take that original base function and we can rewrite it as 1/2 to the power of x over 8. Okay, so for example, if x is 16, then it'd be 16 divided by 8, which is 2, right? If x is 24, then it'd be 24 divided by 8, which is 3. Okay, and now what we have to do is we have to find a. And so the way you can find a is you can use a coordinate. Okay, so it doesn't matter which one you want to use. So let's say we use the first one, which is 0, 100. So what you have here then is y is 100, which equals a to the 1/2, and then 0 divided by 8. And so 1/2 to the power of 0 is going to equal 1, and so a is going to equal 100. So what you have here then is y equals 100 to the power of 1/2 x over 8. Okay, and there's no translation here, so that's all you're left with. Okay, so I'll stop there, and now you can work on the corresponding questions.